evaluate the limit. So we have limit of 1/3 minus 1 over root x plus 5 all over x minus 4 as x tends to 4. As usual, we first simply plug in the x equals 4 into this fraction. Okay, when we plug in the x equals 4, so this is 1/3 minus 1 over root 4 plus 5, 9. So root 9 is 3, by the way. On the bottom, 4 minus 4, 0. So 1 over 3, 1/3 minus 1/3, 0 over 0. So this is not the answer. 0 over 0 is not 0. So in this case, we need to simplify this fraction, and at some point we need to cancel the 0 making factor, which is x minus 4. So x minus 4, so we have x minus 4 hidden on the top, so we need to simplify and get that out and cancel with x minus 4, then plug in the x equals 4. Okay, so for that, look at the top, we have two fractions. Okay, so we have two fractions, so we need to combine. So let me find the common denominator and multiply so that the bottoms are gone. So multiply the top by 3 times quantity x plus 5, and we have to do the same on the bottom. So multiply by 3 root x plus 5. Okay, so this is limit as x tends to 4 of, there was no issue on the bottom, so let's write everything. So 3 times x minus 4 times this, so let me write the number in the front. 3 times quantity x minus 4 times quantity x plus 5. On the top, we multiply a first fraction by this and do the same for the second fraction. And when we multiply, this 3 and 3 cancel, because multiply means multiply the top. 3 cancel, so 1 times root x plus 5 minus, and when we multiply these two, then root x plus 5 cancel, 3 times 1, 3. Okay, so do not cancel these two. So we have minus, means this is not a factor. Now still we have problem. Okay, if we plug in x equals 4, we get 3 minus 3, which is 0 over, and this is 0 making factor. Now we have a square root. So here is the issue. For this, we need to multiply by its conjugate so that the square root is gone. So we need to multiply by the conjugate of the top, because there is issue. So this is conjugate, means x plus 5. We simply change the sign, negative to positive 3, and same thing on the bottom, x plus 5 plus 3. That is limit as x tends to 4 of, and there is no issue on the bottom, so let's write everything. Okay, 3 times x minus 4 times quantity x plus 5 times the whole thing times the quantity root x plus 5 plus 3. On the top, now we multiply. So this is like, let me do over here so that we don't have to write one extra step. This is like u minus v. We know that u minus v, and conjugate means we are multiplying by u plus v. If we multiply FOIL, then middle two terms cancel, so u times u is squared, this two cancel, and we have minus v times v squared. So basically we get first times first minus last times last. I mean, there are two additional terms, but they do cancel. Okay, and we also know that when we have a square root of something, let's say x plus 2, and when we square, so in our case is x plus 5, when we square, and these two cancel as long as this thing is positive, which is the case because x tends to 4. So this is x plus 5, we get x plus 5. Okay, let's come back here and multiply that on the top. So when we multiply the tops, FOIL, middle two terms cancel, so x plus 5 times x plus 5, root x plus 5 times root x plus 5. Using this idea, we get just x plus 5 minus 3 times 3, 9. Okay, now look at here, 5 minus 9, that's negative 4. So basically this is same as, let me simplify so that we don't have to write another step. This is same as x minus 4. So we have only x minus 4 left on the top, which is a factor. Now we can cancel this x minus 4, x minus 4. Okay, that was the zero making factor from the beginning. Now we got rid of that. Then what do we have to do? Simply plug in the x equals 4, because we have nothing left on the top, just 1, and we are not gonna get 0 over 0. So unless we get 0 over 0, we are good. So 1 over, because cancel means 1, this is 3 times x is 4, right? 4 plus 5, 9. Root 9 is 3, so 3 times 3, and here is now 4 plus 5, 9. Root 9 is 3, 3 plus 3, 6. So 3 times 3 times 6, so let's multiply them. So 9 times 6, 54. So the answer is 1 over 54, final.